apabila pihak lawan tertawakan kemampuan. Mentaliti perlu.
Okay, hello and good morning. Today we will discuss about question bisection method. So, for the example question, for a curved beam subject to bending such as a crane hook lifting a load, the location of a natural axis is shown in figure 1 and given by the equation, where r is the radius of the centroidal axis and d is the diameter of the circular cross section of the curved beam. Use bisection method to find the value for d by considering the initial interval 0, 5. Error less and equal to 0.0001 given that Rn equal to 4d when r equal to 10 inch. So you must work your solution in 4 decimal places.
So, firstly, we must understand the question given. After that, take note about the important keywords that already given. Then, it will be more easier for us to solve this problem. As you can see, the given equation by the question is 4Rn in the bracket 2r minus sec 4r squared minus d squared equal to d squared. The question also wants us to use bisection method to find the value for d by considering the initial interval 0, 5. It also given the error which is must be less or equal than 0.0001. The question also give that Rn is equal to 4d when r is 10 inch. First of all, we must substitute 4d into Rn and 10 into r in the equation. As you can see, the equation will be like this, and after substitute to get the new equation, we can see that the equation is now in terms of d squared. Then we already know that function d, so to make a function we must change or arrange the equation to become equal to 0.
So for bisection method, the simple way to solve is create a table which is include n, a, b and which is a plus b divided by 2, and then function of a, function of m, epsilon b minus epsilon m. When n equal to 0, there is no value for the others. After that, continue with n equal to 1. Take 1, 5 as the initial interval because if 0, we cannot get any sign of the value. A or b will be changed next according to sign of function of a and function of m. So, if both signs are equal, the value of b will be replaced by the previous value of m. Then, if sign different, the value of a will be replaced. For this solution, we must calculate continuously until the error reach the error tolerance given, which is 0.0001. From that, we can conclude value d is 2.4903.
Okay, we proceed to question 2, which is A balloon move in the xy plane according to the law x equal to at and y equals to bt power of 2, where a must larger than 0 and b must larger than 0. Okay, so the question A2, we need to determine the balloon trajectory y, x and sketch each graph. Second, the speed of the balloon as a function of t. And 3 Romans, the angle between the velocity vector and the x-axis.
So next question is B. The question is, find the velocity, acceleration and speed of a particle by a position function r of t equal to 2 cos ti plus 3 sin tj at t equal to 0. Sketch the path of the particle and draw the velocity and acceleration vectors of the specified values of t.
So look at the solution here. Graph of balloon trajectory yx. Okay, first they given x equals to at, so we need to derive t equals to x divided by a. So after that we substitute t into the function of y, so we will get y equals to b times x over a power of 2. So if we need to sketch the graph, we must to assume a and b to the something value, which is in this solution we assume a equals to 1, b equals to 1, so we will get the graph, the line graph of blue is for function y equals to b x over a power of 2. So that's for the blue one, and if you see the green one is for the t equals to x over a. Okay, so the 2 Romans question, the speed of the balloon as a function of t, which is time. Okay, so x equals to at, y equals to bt power of 2. So the position vector rt equals to we need to, because it's a vector, so we need to put in as a coordinate, as coordinate. So x, coordinate x will be at and coordinate y will be bt power of 2. So the velocity, we need to differentiate the position vector, which is we'll get a for the x, 2bt for the y. So for the speed, the magnitude of the velocity, so square root, we inside the square root a power of 2 plus 2bt power of 2, which is if we write the general equation, we will get square root and x power of 2 plus y power of 2. So the answer is A plus 2bt. Okay, the next one, the angle between the velocity vector and the x-axis. So when the answer in two Romans, we get velocity vector, which is vt equal to a in the bracket, because vector we write in coordinate. So a for the x, y equal to 2bt. And then we write the tangent power of -1 in column to y over x, which is 2bt over a, because the formula is tangent equal to y over x, but we substitute y equals to 2bt and x equals to a. So if the b and a value given, so we need to substitute the value into the equation. But in this question, we don't have exactly the value for a and b, so we only write the general equation only.
Okay, the equation is we need to find the velocity, acceleration and speed. The equation given, r of t equal to 2 cos ti plus 3 sin tj. First, we need to find the velocity, which is we need to differentiate the equation given. When t equal to 0, it will be 3j. Next, we need to find the acceleration. For the acceleration, we need to differentiate again, which is second derivative, and when t equal to 0, it will be negative 2i. For speed, to find a speed, the equation is modulus v of t equal to sec negative 2 sin t squared plus 3 cos t squared. And the final answer is sec 5 cos squared t plus 4. When t equal to 0, the answer is 3. As we see in the graph, the yellow line is referred to velocity. It is upward because the velocity is positive, and the red line is referred to acceleration. It go to the left because it is negative, and the position is in x-axis because it is I is x-axis, and the blue line is refer to speed. The 3 is the initial speed because when t equal to 0, the speed is 3.